Alright, ladies and gentlemen, this is 12.6 permutations and combinations, part 2. So we're going to start off with what is a permutation? A permutation is an arrangement of objects in a specific order. So we're going to go ahead and draw out the permutations of arranging the letters A, B, and C without repeating. So what you could do is you could start off with a tree. So we're going to say we could have A first, B first, or C first. Then after that you could have either B or C, and then after that it's going to be C and then B. Okay, then you could have A and C here, C and A, and B and A and C. So all of our combinations are A, B, C, A, C, B, B, A, C, B, C, A, C, B, A, and C, this should be B, A, B. So in total we have 6 combinations. So we arranged 3 things and we got a total of 6 different ways to arrange them. Alright, so next we have how many different batting orders can you have with 9 players? So we're gonna kind of look at the counting principle here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 different spots for the batting order. For the first spot, we have 9 choices. Okay, then you can't repeat. So then you have 8, 7, 6, 5, 4, 3, 2, and finally 1 choice for the last one. So multiplying all that out, we get this number. So there are that many ways to arrange 9 players. Now, if let's say you want to do 10 or maybe even 15 different people and rearrange them, this might get a little too hard, but we have key concepts. So the expression NPR represents the number of permutations of n objects arranged R at a time. So we have this formula right here, so you want to copy that down and write it on your notes. And let's go ahead and use that formula. So a band has 7 new songs and wants to put 5 of them on a demo CD. How many arrangements of 5 songs are possible? So we're going to go ahead and copy the formula. All right, and so n is a total number. So in this case, n equals 7, and then R is the number of items you're arranging. So that would be 5. Okay, and we call this, so this would be 7 permutation 5, and we're going to rewrite that as 7 factorial. So by the way, this exclamation is a factorial. It's not excited math. And then 7 minus 5, that's 2 factorial. So I'm going to show you how to write out a factorial. A factorial is going to be 7 factorial is 7 times 6 times 5 times 4 times 3 all the way to 1. And so therefore 2 factorial is 2 times 1. So these cancel each other out. And then I just have to find what 7 times 6 times 5 times 4 times 3, and you would be using a calculator for that. So that is going to give you 2,520 permutations or arrangements. And then when you do get into Algebra 2, we will teach you how to plug this into your calculator. but if you did want to look that up, you can. Alright, so next we have combinations, which is a selection of objects without regards to order. So order does not matter. For example, if you have a selection of 2 side dishes from a list of 5, the order doesn't matter because it doesn't matter in what order you place the side dishes, you're still going to eat them. Alright, so here we have the formula. N choose R, where N is the total number of objects and R is the ones you're choosing. And so again, go ahead and copy this down. Alright, this is example number 3. 20 people report for jury duty. How many different 12-person juries can be chosen? So first thing we're going to do is we're going to go ahead and write down our formula. N choose R, and that is going to be N factorial over R factorial N minus R. Okay, and so N again is the total number of people. So that's 20 people that we could choose from, and we want to choose 12. So that's going to be 20 choose 12. Okay, so it's going to be 20 factorial over 12 factorial, and then 20 minus 12, which is 8 factorial. Alright, so let's go ahead and write 20, 19, 18, 17, 16, 15, 13, 12. Now technically I could do 12 times 11 and then continue going, but I could also decide to end my factorial instead of writing it all out. And so what that's going to do is that's going to allow me to get rid of the 12 on the bottom. So I'm going to just expand the 8 factorial. So 8 times 7 times 6, 5, 4, 3, 2, and 1. Alright, so we're going to go ahead and cancel out the 12s. And then what we're going to do is we're going to try to simplify the rest. So I know that 15 divided by 5 is 3. And this 3 divided by 3 cancel each other out. 16 divided by 4 is 4. And then this 4 divided by this 2 is 2. Then we have 6. I could divide 18 and 6, and I'm going to get 3. Okay, then I also miss 14 here, so I'm going to write 14 in there. 14 divided by 7 is 2. And let's see, for the 8, we'll go ahead and divide 20 and 8 both by 2, so that's going to be 4 and 10. And I could divide it by 4 or by 2 again. Okay, and then this 2 and this 2 cancel each other out. So I'm going to go ahead and write on the top I have left 5 times 19 times 3 times 17 times 2 times 13, and then on the bottom I have nothing left. So we're going to go ahead and multiply all that out, and we get 125,970 different ways to arrange these people. So this is example number 4 here. In how many different ways can we choose 3 types of flowers for a bouquet from a selection of 15 flowers? So let's write down the formula. And then let's go ahead and fill it in. So N is equal to 15 and R is 3 because we're choosing 3. So we have 15 factorial over 3 factorial, and then 15 minus 3, that's going to be 12 factorial. Okay, so I'm going to write this out. So 15 times 14 times 13. Oh, then I see 12 factorial on the bottom here, so I'm going to leave the factorial here. And then you have 3 times 2 times 1 and 12 factorial. So I'm going to go ahead and cancel out the 12 factorial. Then 15 divided by 3 is 5, and 7 divided by 2 is, or 14 divided by 2 is 7, and then the 1, I don't really need to worry about that one, I could get rid of it. So multiplying this out, I get 455 ways to rearrange. Alright, and the last thing is, here is your homework. So I combined both permutations and combinations.